Hello. This is part one of practice problems involving derivatives. So in this video, we're just going to do some practice problems involving derivatives. So if you forgot how to do certain techniques of deriving, please check out my video lectures for derivatives. So by now, you should have a good idea how to do you should understand the different techniques of deriving. So let's start with number one. So for the following examples, find y prime for the following examples. So on number one, we have y equals parentheses 4x squared plus 1 raised to the second power. And we want to find y prime, first derivative. So what would be the best technique? I would definitely use chain rule and power rule, right? So this is going to be y prime. And then using power rule, this would be 2. And then the inside stays the same. And then this 2 becomes a 1 because of the power rule. And then you times it by the derivative of the inside. So the derivative of 4x squared is 8x. The derivative of 1 is just 0, or a constant. Yeah, 0, right? So this would be 2 times 8 is 16x. This would be 4x squared plus 1. And when you FOIL it out, you can leave it like this, or you could do one more step, FOIL it out, and you'll get 64 x cubed plus 16x. Okay, so that is your first derivative, your y prime, or your slope. Yeah, so if you forgot how to do chain rule, please go ahead and review. And let's do example 2. Y equals parentheses x5 plus 3x raised to the second. So just like number one, we're definitely going to use power rule and chain rule. So you're going to put the 2 in front of the parentheses. So it's 2 parentheses x5 plus 3x. And then the power is going to be 2 minus 1, which is 1. And then you take the derivative of the inside. So the derivative of x5 is 5x to the 4th. The derivative of 3x is just positive 3. And when you boil it up, clean it up a little, you get 10x to the 4th plus 6 parentheses x5 plus 3x. And then when you FOIL it out and combine like terms, your final answer would be this. 10x to the 9 plus 36 x to the 5 plus 18x. Okay. So yes, we did power rule and chain rule. Let's do number 3. So y equals 11x to the 7th. So we're definitely going to use just power rule, right? 11 is a constant, so you could just, how I think of it is just take it out for a moment. So you're going to multiply 7 by 11, which is 77. And then the new power for x is going to be 6 because 7 minus 1 is 6. So your final answer is this. Let's move on to 4. We have y equals 18x cubed plus 12x plus 11. So y prime is going to be the derivative. So I think we're just going to use power rule, right? So the derivative of 18x cubed would be you multiply 18 by 3, which is 54. And the new power would be 2 because 3 minus 1 is 2. The derivative of 12x is just 12. And then the derivative of 11 or a constant is 0. So, yep, this would be your final answer. Okay, example 5. Y equals 1/2 times x 12, x raised to the 12 plus 17. So what would I do? I would, you know what I would do? I would, since 1/2 is a constant, just take it out for a moment and then just take the derivative of the inside. So there's no chain rule for this one because this is raised to the 1. So the derivative of x12 is 12x to the 11. The derivative of 17 is 0. Of a constant is 0. So it's going to be y prime, and then FOIL out the 1/2. So 12 times 1/2 is 6x to the 11. And then 1/2 times 0 is 0. So this is why this is your final answer. Okay, let's move on to 6. So just like 5, you can take out the constant -1/3, and then just take the derivative of the inside. So the derivative of x9 is 9x to the 8th. The derivative of 2x cubed is, so it's going to be 3 times 2, which is 6x, and then the power is going to be 3 minus 1 is 2. And then the derivative of -9 is a constant, which is 0. You don't have to put the 0 if you don't want to. Then FOIL out this -1/3, so it's going to be y prime equals to -3x to the 8th. -1/3 times 6 is -2x squared. And then -1/3 times 0 is just 0. Okay, number 7, we have y equals pi to the 5. Don't be fooled. This is pi to the 5 is a number. There's no x, there's no letters. So we know that the derivative of any constant is always going to be 0. So y prime is going to be 0. Okay, number 8. To take the derivative of this one, I think you just apply power rule. So it's y prime equals, so you do -8 times -8, which is positive 64 x, and then -8 minus 1 is -9. And oops, I'm missing something, sorry. So it's missing part of the problem. So on number 8, it's going to be -8x to the -8 plus 12 radical x. What I would do is maybe I could put everything in terms of power. So I could rewrite this as -8x to the -8, and then plus 12 square root of x, like in power form, that's equal, square root of x in power form would be equal to saying x to the 1/2. And then y prime is going to be -8, and -8 is positive 64. -8 minus 1 is -9. Plus 12 times 1/2 is 6. And then 1/2 minus 2 over 2, which is -1/2. And then I guess if they ever ask you to put it in only positive form, your final answer would be 64, and then times. How do I write x to the -9 as a positive? It would be 1 over x to the 9 plus 6 times 1 over x to the positive 1/2. And then your final answer would be, so y prime would be 64 x to the 9 plus 6 over square root of x. Okay, so that would be your final answer. Number 9, we have y equals 6x to the negative 7 minus 4 radical x. So if you, well, so this one, actually, what should we do? Just like number 8, let's put everything in power form. So this would be equivalent to saying negative 4x to the 1/2. So y prime would be 6 times negative 7 is negative 42. X. Negative 7 minus 1 is negative 8. Minus 4 to the 1/2 is 2. X. And then 1/2 minus 2 over 2 is negative 1/2. And then let's put everything in positive. So this would be negative 42 x to the 8. And then this is going to be minus 2 over radical x. Okay, so remember, x to the negative 1/2 is the same thing as 1 over x to the 1/2, positive half, and then that's equivalent to saying 1 over x to the 1/2 is the same thing as the square root of x. So that's why there's a radical x in the bottom. Number 10, we have y equals x to the negative 5 plus 1 over x to the 8th. So if you look at this, it looks a bit weird, but what I would do is convert it. It's kind of like going backwards now. Instead of using positive power, maybe I can make this as a negative power. So 1 over x to the 8th in negative power form would be equivalent to saying x to the negative 8th. So take y prime and then take the derivative of each term using power rules. So the derivative of x to the negative 5 is negative 5x to the negative 6. The derivative of x to the negative 8 is the same thing as negative 8x to the negative 9. And then let's put our final answer using only positive power. So it's going to be y prime equals to negative 5 over x to the 6. This would be negative 8 over x to the 9th. So this would be your final answer. Number 11, we have y equals 6x squared plus 3 times 12x minus 4. You definitely, what you could do is FOIL it out, collect like terms, and take the derivative of each term, right? Or you can also do the product rule. So since I'm lazy, I am going to do the product rule. And if you recall, product rule is f prime of g plus g prime of f. So maybe this whole thing could be my f, and then this whole thing could be my g. So yes, f equals 6x squared plus 3. And then f prime is going to be 6, the derivative of 6x squared is 12x to the 1, and then the derivative of 3 is 0. And then g is going to be 12x minus 4. So g prime is going to be, the derivative of 12x is just 12, and the derivative of negative 4 is just 0. Okay, so just put it apply the product rule. So it's going to be y prime equals to f prime, which is 12x, times g, which is 12x minus 4, plus g prime, which is 12, times f, which is 6x squared plus 3. Okay, so when you FOIL it out and collect like terms, okay, so it would be y prime equals to 144. And then when you collect like terms, it's going to be y prime equals to 216 x squared. So this is your final answer. Let's do 12. So just like 11, you definitely got to do, I would definitely apply the product rule. So maybe on 12, my f is this, and then this whole thing would be my g, right? So f equals 3 minus x minus 2x cubed, and then f prime would be the derivative of 3 is 0, the derivative of negative x is -1. The derivative of negative 2x cubed would be negative 6x squared. So that would be -1 minus 6x squared. And then g would be 6 plus x to the 4th. So g prime would be 0 plus 4x cubed. So that would be 4x cubed. So apply the product rule. So it's going to be y prime equals to product rule is f prime of g plus g prime of f. Okay, so f prime is -1 minus 6x squared times regular g, which is 6 plus x to the 4th, plus g prime, which is 4x cubed times 3 minus x minus 2x cubed. And when you multiply, FOIL, and collect like terms, your final answer is going to be this. Okay, let's move on to 13. This one's not bad because they're all constants, right? So the derivative of e to the 10, that is technically a number. I don't know what that is, but it is a number. So that's the derivative of a number or a constant 0. The derivative of pi cubed is a number as well, so that's 0. And the derivative of -7, that's the 0 as well. So it's just going to be y prime equals to 0. Okay, 14 looks kind of crazy, but what have I would do? I would, before I FOIL it out one by one, maybe I could just, I don't think I will do the product rule. What I'll do is just clean this up and then maybe just take the derivative of each term. So let's simplify this. You're adding fractions, so you need a common denominator. So if you look here, we have an x. Over here, we have an x squared, so my common denominator would be x squared. So over here, you're going to multiply top and bottom by x. So x times 1 is x plus 1 over x squared. The derivative of 4 over x cubed minus 6 over x4, this would be x times x. That would be 4x. So that would be 4x minus 6 over x to the 4th. And what would I do next? I would clean this up. So when you're multiplying fractions, you multiply across. So x2 times x4 is x6. And then when you multiply, when you FOIL out the numerator, you get 4x squared minus 2x minus 6, right? Then what I would do is divide each term by x6. So what I mean is like do 4x squared over x6 minus 2x over x6 minus 6 over x6. And when you finally so over here, you're going to get y prime equals to 4x. So when you're dividing with the same base, you subtract the power. So 2 minus 6 is -4 minus 2x. This has the power 1, so 1 minus 6 is -5 minus 6. I'll over x. Well, I can write this as x to the -6. Then I just apply the power rule. So this would be the derivative of 4x to the -4 is the same thing as -16 x to the -5. The derivative of -2 and -5 is +10 x to the -6. The derivative of -6 x to the -6 is +36 x to the -7. And then your final answer is okay. So this is your final answer using positive powers. Okay, almost done. 15. The derivative of y equals radical x plus 1 over square root of 3. What I would do is, if you can, rewrite it as only powers. So square root of x is the same thing as x to the 1/2. 1 over this, 1 over square root is, well, that's the same thing as 3 to the 1/2. And then if you want to write this as a negative, this would be 3 to the -1/2. So y prime is going to be 1/2 x to the -1/2. And this is easy, right? The derivative, this is still technically a number. There's no x. So the derivative of a constant is 0. And then using only positive power, it would be 1 over 2x to the 1/2. And then your final answer is going to be 1 over 2 radical x. So that's your final answer. And then let's do 16. We have y equals 0, so the derivative of that would be, right, it's a constant, so it's just going to be 0. And 17, what are we going to do? We're going to do power rule and chain rule. So this is going to be 3 parentheses x plus 1 to the second times the derivative using chain rule, take the derivative of the inside. So that's going to be the derivative of x is just 1. The derivative of 1 is 0. So you get 3. You can leave your answer as this x plus 1 squared. I mean, or you can go further and FOIL it out, like terms. But right now, I'm just going to leave it like this. Okay, 18, we have y equals radical x plus cube root of x plus 3 of the cube root of x squared. So what I would do is write it only using exponents. So radical x in power form is equal to saying x to the 1/2 plus the cube root of x in power form would be saying x to the 1/3 plus the cube root of x squared is the same thing as x to the 2/3. And then just take the derivative using power rules. So this would be 1/2 x to the negative 1/2. Why is it negative 1/2? Because 1/2 minus 1, or you can say 1 as 2/2, is the same thing as negative 1/2. Plus, so 1 times 1/3 is 1/3 x, and then 1/3 minus 1 will give you negative 2/3. And plus x to the 2/3 is equivalent to saying 2/3 x, and then 2/3 minus 1. That's negative 1/2. And then when you put this in positive power, this is going to be y prime equals to 1/2 square root of x plus 1/3 x to the 2/3 plus 2/3 x to the 1/3. And I guess you could put your final answer in radical form. So I guess your final answer would be y prime equals to 1/2 radical x plus 1/3. And then x to the 2/3 is equal to saying the cube root of x squared. Plus, this is equal to saying 2/3 and then the cube root of x. Final answer. 19, almost done. There's 20, so just 2 more. So what would I do? I think I would apply the product rule, but before I apply the product rule, I'm going to FOIL this thing right now. So it's going to be x, and then when you multiply and collect like terms, so when you FOIL this out, this is going to be 2x squared minus 4x plus 7x minus 14. And just now apply the product rules. So if f is x, f prime would be 1. If g is this, g prime would be 4x plus 3. Okay, so y prime is going to be when you apply the product rule, so f prime of g plus g prime of f. So when you FOIL it out and collect like terms, I'm just going to write out the answer. When you FOIL it out and collect like term, it's going to be, your final answer would be 6x squared plus 6x minus 14. Okay, last one, 20. What I would do is write it out as everything as a power and then FOIL it out. And then I think the best thing you would do is just take the derivative of each term. So what I mean is radical x could be expressed as x to the 1/2 And then the cube root of x is the same thing as x to the 1/3 plus the 5th root of x is equivalent to saying x to the 1/5. And then FOIL it out. So remember, the rule is when you're multiplying with the same base, you add the power. So when you multiply x to the 1/2 times x to the 1/3 is equivalent to saying x to the, so you would add the power 1/2 plus 1/3. Common denominator would be 6. So this would be e⁻³ e⁻². So this is equivalent to saying x to the 5/6. And then over here, when you multiply this out, this is equivalent to saying 1/2 plus 1/5. So 5 plus 2 is 7. So that's equivalent to saying plus x to the 7/10. Okay. And then just use simple power rule. So this is going to be y prime equals to 5, 6, x. And then if you do 5, 6 minus 1 or 6/6, that's -1/6. Plus, and then the derivative of this is going to be 7/10 x, and then 7/10 minus 1 or 10/10. That's negative, what is that, -3/10. And then when you use only positive power, it's going to be 5/6 x to the 1/6 plus 7/10 x to the 3/10. And then if you want to put it in your final answer in radical form, that's fine. So that your final answer could be expressed as this: 5/6, the 6th root of x, plus 7/10. And then this is going to be this, this is going to be the 10th root of x to the 3rd. Okay, so that's it. That should be a review. And then, yeah, that's it for today. Okay, thank you. Bye-bye.